Good afternoon. Welcome back to Zoology first year class. We are in the SAQs, fifth lesson SAQs. We started yesterday only. Already I explained the types of flagella here in this. The locomotion and reproduction in protozoans. Locomotion and reproduction in protozoans. In this, the 4 SAQs are important. First one is the types of flagella. Already we discussed types of flagella. And second, I am going to explain about the binary fission, transverse binary fission in paramecium. Transverse binary fission in paramecium. Next, the third one is called as the longitudinal binary fission in euglena. Next, last one is types of flagella over now, types of pseudopodia. Types of pseudopodia. These compulsory out of these 4, one will be compulsory in the exam. That's why already I completed the types of flagella. The 5 types are there. They will discuss tychonematic, the pantonymatic, acronematic, pantacronematic, and the anematic. Here, next we are going to discuss about the transverse binary fission and the paramecium. Clear? Normally, the binary fission, bi means 2. The fission means they divided. The parent individual is the parent is divided into daughter individuals is called as a binary fission. How it is means for example, parent individual is there. That parent individual is divided into 2 individuals. Bi means 2 daughter individuals are. Fission means divide. Fusion is different. Fission is different. Fusion means joining. The fission means divide. The parent individual is divided and form it as a 2 daughter individuals. That process is called as a binary fission. The binary fission is present in the euglena as well as in the paramecium. In the euglena, the binary fission is called euglena. The binary fission is called as the longitudinal binary fission. Longitudinal binary. Why we call it a longitudinal binary fission means they are longitudinally divided, not in the paramecium. Paramecium transverse. In the euglena, they are vertically, they are divided into 2 individuals. That's why we call it a longitudinal. In paramecium, that is the transverse. Means the horizontally they can divide. That's why we call it a transfer. 2 types of binary fissions are there. That we are first one. We are the transverse binary fission. We are going to discuss here. See, observe the diagram here. This is the paramecium. Is having this one inside of the paramecium. The structure is like this. The inside of that 2 nuclei is present. The one is called as a macronucleus. Bigger one is called as a macronucleus. Smaller one is called as a micronucleus. Here the one thing in the binary fission means the parent individual is divided into 2 daughter individuals. First, in that process, first the karyokinesis is occur. Here what it is? First the karyokinesis. Karyokinesis is occur. That is next form it as a cytokinesis. Cytoplasm is divided. Kinesis means divide. Here first The karyokinesis means the first nucleus is undergoes divide. After that, the cytoplasm is divided. That's why we call as that process is called as a binary. Binary fission means the karyokinesis is the after the karyokinesis, cytokinesis is occur. That we call as a binary fission. The depending upon the dividing of the cytoplasm, two types are there: transverse binary fission, longitudinal. Here, in the paramecium, transverse binary fission is occur. First, here the structurally the two macro and micro nucleus is present, and the two contractile vacuoles are present. This one is the anterior contractile vacuole. This one is called as a posterior contractile vacuole. Two contractile vacuoles are present, and the two nuclei is present inside. And also this one is called as a oral groove. Oral groove is present. This is cytopharynx, and this is called oral groove is present. Near here, see this one. Paramecium undergoes the transverse binary fission during which time? Favorable conditions. Food is sufficient, water is sufficient, climatic conditions are good. That time only, in the favorable conditions only, the paramecium undergoes the fission, transverse binary fission. Before the binary fission, it stops the feeding, and the oral groove is disappear. Before only, they are stops the feeding, means their food is not taking, and also they are here the oral groove. See this one here, it is a full oral groove is there. That will be dotted, means oral groove will be disappear. Before the binary fission, first they stop the feeding and the oral groove is disappear. After the disappearance of that, next step, the micronucleus is there. Here this one is called as a micronucleus. The bigger the bean shape is there, that we call as a macronucleus. Here, the micronucleus divides into two by the mitosis division. Here, mitosis and amitosis. Equally they are divided, equal size they are dividing, that we call as a mitotic division. Unequally means the here it is one is a big, one is a small. That we call it as the amitosis. Here, the what it is? Micronucleus divides into two by mitosis division. Micronucleus in the divided into two through mitosis division. Next, the macronucleus divided by amitosis. Here, unequally they are dividing. Here, next a transverse after the karyokinesis is over. Up to here, see this one. Up to here, the karyokinesis is over. After the karyokinesis is finished, here the constriction, the folding will occur. It's like this, the folding. Here it is a macronucleus is dividing. Here also micronucleus is dividing. After the division of the nuclei, here what will happen? The transverse constriction appear in the middle. One constriction is occur. Here it deepens. This constriction next step, you see that it is deepens. Here it deepens and divided the parent into two daughter individuals. See this one, anterior one and the posterior one daughter individual is formed. While the forming time, which organelles are taking the anterior one, which organelles are taking by the posterior one, and which one they can own, they can prepare, we are going to discuss here. First anterior daughter individual. Here, the anterior is called as a proter. Anterior one is called as a proter, and posterior one is called as a opiste. This one is a proter, and this one is called as a opiste. Here, after the constriction is occur, constriction is deepened and form it as a two daughter individuals. Anterior one is formed and posterior one is formed. Anterior one is called as a proter. Posterior one is called as a opiste. Here, next each daughter is at one contractile vacuole. This is taken by this one. This one is taken by this one. Here, anterior one taken by the anterior daughter individual, and the posterior one contractile vacuole taken by the posterior daughter individual. Here, like this. Here, next the opiste receive the posterior contractile vacuole along with the macro and micronucleus. Here, each daughter individual gets one contractile vacuole to run the parent, and second vacuole is they can prepare their own. What about the opiste? Opiste receives the posterior contractile vacuole, along with the micro and the macronuclei from the parent. Next, the missing the organelles are newly developed by both. Which one is missing? Means here the contractile vacuole, anterior one is taken by the anterior proter. Posterior one is taken by proter. Oral grooves are there now. These oral grooves already disappear. They can prepare their own. Here, macronucleus, they're taken from the parent, and anterior one taken the anterior contractile vacuole by the parent. Posterior one taken the posterior contractile vacuole. Remaining all the organelles are, they can prepare their own. Here, just like this, the binary fission is completed in 2 hours. Clear? This one is about the simply transverse binary fission means horizontally they are dividing. Here, the main step, karyokinesis followed by the cytokinesis. Normally, the paramecium is like this, and first macronucleus undergoes divide amitotically, micronucleus divide mitotically. Before that only, the oral groove is disappear. When they undergoes the binary fission, they starting of the binary fission, oral groove is disappear first, and they can't take any food. And next, this one is started, the division. Macronucleus undergoes division amitotically, and the micronucleus division by the mitotically. After the division of the nucleus, here the one transverse constriction is occur in the middle. Constriction means one line is formed. This constriction deepen and form it as a 2 daughter individuals. Anterior one is called as a proter, posterior one is called as a opiste. Proter takes the anterior contractile vacuole from the parent. Posterior contractile vacuole, they can prepare their own food. Which one is preparing? Proter. Proter prepare one, the posterior contractile vacuole, oral groove. Here, that's all. Here, next, what about the opiste? Opiste is taken the posterior contractile vacuole and prepare the anterior contractile vacuole and the oral groove. Here, like this, they are forming the transverse binary fission. Here, in the binary fission, it takes the 2 hours, means for total completion, the 2 hours will be required. Here. Next, we are going to discuss about the next one, that is called as the longitudinal binary fission. The diagrams are very, very important. See this one, how the paramecium diagram, just I am giving the outline only. Just see, like this you draw it. Just round you like this, draw it. And after that, the oral groove, you draw it like this and like this, simply. Here the macronucleus, and this one is the micronucleus. One round is the anterior side, one round you draw it in the posterior. This is the actual original, the paramecium. The second, what you are doing, the second condition, what you are doing, this one is second. See this one, here you are drawing like this only. Oral groove, draw it as a dotted lines. The oral groove is disappear. And here the anterior contractile vacuole, posterior contractile vacuole, just the shape we change it. Here the macronucleus undergoes started to the division. Here like this, second step. The third, what it is, the third you observe here, you draw it as a slipper shape, almost like this. The middle, the slight constriction is up here. And this one is enlarger. Here macronucleus is enlarged. Draw it, and put the dots here and here and join it both like this. And the same contractile vacuoles here and here also one is there. Sorry, here also one is there. Next what it is? Next step, to draw between them line is formed. Here, after the formation of line, here one contractile vacuole is there, down one contractile vacuole. Between them, oral groove is in this one oral groove is there, and in this also one oral groove is there. Before that also same oral groove here also formed, here also formed. Here, next the macronucleus, micro, macronucleus, micro. That's all. Both the contractile vacuoles are appear. They can divide and form it as here one and here also one. Here, next in this also oral groove is there. All the same like a contractile vacuole. Here one contractile vacuole. Here also this one. Here the oral groove is up here and the macro, micro contractile vacuoles. Here, like this, we try to draw the diagram. Simple diagram, labeling is important. We draw it. Next, we are going to discuss about the transverse binary fission. Sorry, longitudinal binary fission. Normally here, simple technique in the transverse binary fission and the longitudinal binary fission. First, nucleus is undergoes divide. Afterwards, cytoplasm. Depending upon the cytoplasmic division side, we called it as a transverse binary fission and the longitudinal binary fission. See this one more. This is a longitudinal binary fission in euglena. In the paramecium, don't confuse. Both of them are every time you are get confused. The transverse binary fission every time present in the paramecium. Longitudinal binary fission is present in euglena. Here, the paramecium is locomotory organelle. The cilia is present. Here, the euglena, the cilia is present. The flagella is present. Long whip-like flagella is present. See this one. The euglena undergoes the longitudinal binary fission. Same this first point of the paramecium transverse binary fission. Euglena undergoes the longitudinal binary fission during the favorable conditions. The water is sufficient, food is sufficient, the environmental conditions are sufficient. That time only they undergoes the binary fission. Here, the next is the during this process. What is the stigma? Here I'm drawing here the diagram. See this one. What is stigma? Here it is not clearly visible. See. Like this, you draw it the simple way. You draw it like this. Here and here the one small and the one large flagella is present. Smaller is not visible, only longer are visible. And this one is called as a dark line is there, that we call as a stigma. Here, the chromatin is there. Here it is called as a stigma. Here, next is the center, the nucleus is there. And also here the contractile vacuole also present here. Anywhere you draw it, the contractile vacuole is present. And how it is made, see this one. During the process, the stigma, paraflagellar body, contractile vacuoles are disappear. This one is disappear. And one more is there that is called as a paraflagellar body that will be disappear. And also this contractile vacuole also disappear. During the binary fission, which one is disappear? Stigma is disappear. Paraflagellar body is disappear contractile vacuole also disappear. Nucleus is like that only. Next, the nucleus, basal granules, chromatophores, cytoplasm is undergoes division. What are the chromatophores? Like this, the dotted lines are there that we call as a chromatophores. Chromatophores are undergoes divide, and the which one? The basal granules. Here the starting of the flagella, small and large flagella. Here the basal granules where they are arise, where the flagella is arise, that we call as a basal granules are there. That granules also undergoes divide. Which one? See this one first, the nucleus automatic. All of you know this divide. Next, basal granules are divide, chromatophores are divide, and cytoplasm is also divide. Here, four are divided. Here, nucleus, basal granule, chromatophores, cytoplasm is undergoes divide. Here, after the dividing of this, a longitudinal, see this, observe here. Here they are divided and form it as a two flagella is formed. This side one flagella is formed. Observe the first and second diagram. In the first diagram, only one flagella is there. In the second diagram, the kinetosomes, basal granules are two. They are divided into two. That's why here two are formed, here two are formed. Here means the one is a smaller flagella, one is a larger flagella. Like this, they are formed. After that, the nucleus is undergoes. Here, nucleus is also undergoes divide, and here one constriction is appear. Constriction means longitudinal groove is appear. See this one. A longitudinal groove appear in the central part of the anterior end. The one groove is appeared. That groove comes and deepen and divides the euglena into two daughter individuals. See this one. Gradually, it extends posterior and divides the organism into two. Here, one daughter euglena retains the parental flagella. Other daughter individual takes they can prepare their own. Here, one is taken from the parent, another is formed by the, which one? They can prepare their own. Here, next. This one is diagram. So see the diagram. See this one? Here, first diagram, see this. Like this, you draw it. Already I draw on side. Here, only one nucleus and same normal. This one is the paramecium, euglena. And the next time what you did means the same like that only you draw it. Same like that only you draw it. The flagellas are two, you draw it. This one is a second. This one is first stage. This one is the second stage. And third stage time, what you are doing means third step time. You draw like this. Two are here the cytopharynx are draw it two. Like this you draw. See this one, observe here, and here one stigma, and here one stigma, flagellar body. The two are the flagellas are occur in this one. Next, the elongation of the nucleus, you draw it, this one. After that, what will happen? Here the groove is formed. Here, the next fourth, how you draw it means, say this one here, and this one is a longitudinal groove, and like this. You try to practice this one. The groove. This one is a groove. This one is one flagella, and this one is a one flagella. Practice the diagram. For the diagram only, you get the 2 marks. Here the same. The nucleus just like this. Almost they are dividing. Like this you draw. This one is a fourth. And what about the fifth? Fifth I am drawing here. See, here both of them are separated. In the middle, they are attached. Here like this. See, this one is a one flagella. This one is one flagella. Here, nucleus, the stigma, paraflagellar body, and like this. Here, this is called as a, next down it is there. This type is called as a, here it is not given, but there. The daughter is formed like a mirror images. See this one, the daughter individuals. See, as daughter is individuals formed like a mirror images. They are looking like a, they are each other same. That's why we call as a, the like mirror images. The fission is called as a symmetrogenic division. Sometimes for the VSAQ is also important. What is the symmetrogenic means? After the longitudinal binary fission, euglena daughter individuals are same like a mirror images. That type of division is called as a symmetrogenic division. Here, this one is about the longitudinal binary fission in euglena. Next one is this one is the last SAQ. In this lesson, fifth lesson, this one is the last SAQ. What it is means here, it is the types of pseudopodia. The pseudopodia are the cytoplasmic extensions. Depending upon the shape, the pseudopodia is different types are there. See this one here, the pseudopodia means the false feet. That is they are temporarily formed in the locomotion. They are temporarily cytoplasmic extensions. They are the helpful in the food collection of the rhizopores. Here they are extension, already I said, extension of the cytoplasmic processes. Clear? Next, the pseudopodia are mainly the four types of pseudopodia are present. They are called as a, first one is called as a, I'm writing here, see, types of pseudopodia. Pseudopodia are the temporary cytoplasmic extensions. They are helpful for the food collection in the rhizopores. The first one is called as a, first type is called as a lobopodia. Lobopodia. These lobopodia, these are the blunt and finger-like. Blunt, see this one like this. Blunt and say amoeba. Amoeba is having like this only. Blunt, finger-like pseudopodia. Example, amoeba and entamoeba. Parasites, entamoeba we discussed now. Trophozoite stage. That trophozoite stage is having the pseudopodia na. That is the lobopodia only. Here, like this, what it is means, they are, for example, see this one, amoeba. It's like this. They are having the finger-like, fingertip-like structure is formed, amoeba. Here, center, the nucleus and the contractile vacuole, the cytoplasm. Just rough diagram, you draw it like this. The lobopodia means blunt finger-like pseudopodia. Example, you write it, amoeba and the entamoeba. Amoeba and entamoeba. Anyone also you can write. Here, that is called as a, which one? The how it is? Blunt finger-like pseudopodia. Example is amoeba and entamoeba. Next, the second is the Hilopodia. The Philopodia means filamentous pseudopodia. It is looking like a filament-like. You observe here, this one is down. This one is the organism, euglypha. This one is the organism. Down of that, the filament-like structures are present, like this. The filament-like structure is present. See, this one is covered by the membrane. Inside of that, the nucleus, all the cytoplasm like this is present. And see this one here, it is a Philopodia. That example is euglypha. This one is euglypha. Animal name is euglypha. Here you draw it like this. Clear? This one is about the Philopodia. First, they are the blunt finger-like is called as a Lobopodia. If they are having the filament shape or filamentous pseudopodia, that we call as a Philopodia. Example is euglypha. Next is the Reticulopodia. Means, see here the Reticulopodia means here they are having the like this. They are the filamentous only, but all the filaments are combined like this. All the filaments are combined and form it as a net-like they are formed. Here, net-like pseudopodia is formed. That's why we call it as a Reticulopodia. This is not only useful for the locomotion, they are useful for the food capturing as also. Clear? But it is C. Reticulopodia. Means they are the same filament and filaments are having the branch. See, I'll write clearly. I'll draw here. See this one, euglypha. Not euglypha. This one, Elphidium. Elphidium is example for this one. This they are form it as a net-like. The branches are there. These branches are form it as a net-like structures. That's why it is called as a Reticulopodia. It is helpful in the locomotion as well as the food collection. Next, last one is called as a Axopodia. They are ray-like, sun ray-like pseudopodia. And see this one here, they are the structure, see, the like this. Surrounding that, see this one, ray-like. The surrounding, same like a sun ray-like, they are present. That's why we call as a actino. See, like this, Axopodia. These are called as a Axopodia. Example is actinophase. Here in this example is Elphidium. Here, this one is called as a actinophase. Yeah, with this, the types of pseudopodia are the mainly temporary cytoplasmic extensions. They are depending upon the shape. There are 4 types are there. They are called as a Lobopodia. The Lobopodia is a blunt finger-like pseudopodia. Example, you can write it as a amoeba or entamoeba. Next, second type is called as a Philopodia. In the name only there, filamentous pseudopodia. Examples compulsory, you write it. For this, examples are important. The euglypha is the example for Philopodia. Next is the Reticulopodia. Reticulopodia, which one? Are the net-like. The filament only there, they are formed as a net. That's why we call it as a net-like pseudopodia. Example, Elphidium. Here the euglypha, In this, here the Helphidium. Next is the Axopodia, or also called as the Hilopodia. Next, it is the ray-like, sun ray-like type of pseudopodia. They are example is actinophytes. How the formation also given, how they are. Next is how the formation, here formation of pseudopodia. Pseudopodia is formed by the conversion of the gel cytoplasm into the sol. Means, see this one, I will explain this, what is the sol and what is the gel. Formation of pseudopodia. Formation of pseudopodia. Here, see this one, sol gel theory means for example, this one is the amoeba, and the amoeba is having the cytoplasm is present. The cytoplasm is divided into the outer ectoplasm and the inner endoplasm. Dotted lines here. The inner, the nucleus is there, same. All of you know this one, and the contractile vacuole is there. Inner is called as the endoplasm. Endoplasm, and the outer is called as the ectoplasm. Here we considered as a inner side we called as a gel. Sol, outer side is called as sol. Sol every time converted into gel means sol is losing the one place, they are losing the water, means they are losing the water. Sorry, the sol is losing the water and form it as a gel. Gel is adding the water and form it as a sol. Here in this place, the gel is added plus H2O and comes as a sol. Sol is losing the water and form it as a here gel. Here like this, sol gel. Gel is present inside, the sol is outside. Here, sol is converted into gel, gel is converted into sol. That process is called as a sol gel theory. This is the most acceptable theory. See, some theories are explained about the formation of the pseudopodia. Sol gel theory is the acceptable theory, and the Allen theory is a front contraction or fountain zone. Fountain like the cytoplasm is pushed and form it as a cytoplasm, form it as a pseudopodia is said. Here, next is the actin and myosin molecules also have a role. And pseudopodial movements or amoeboid movements are performed by amoeba, entamoeba, macrophages, and amoeboid movements are not occur by the only amoeba. That is occur by the mainly the amoeba, entamoeba is performed, and the specially macrophages. What are the macrophages? In our blood, the special cells are there. They are called as a macrophages and the neutrophils. They are also perform the amoeboid locomotion only. Clear? Next. These four SAQs are important from the 5th lesson, and in the 5th lesson, the VSAQ is also important. If that now time is there, that's why I try to explain some VSAQs. Next, and in this lesson only, the VSAQ, important VSAQ is there, that is called as a kinety. The kinety means the kinetosomes and kinetodesmata collectively called one row of kinetosomes. What it is? Kinetosomes plus kinetodesmata. longitudinal row of kinetosomes. Kinetodesmata is called as a kinety. They connected with the motorium. See this one, for example, this is the paramecium. Down of the pellicle, number of the round structures are present. They are called as a kinetosomes. Kinetosomes are connected by thread-like structures. They are called as a kinetodesmata. Longitudinal row of kinetosomes connected by the thread-like, that is called as a kinetod. These are the kinetosomes. Kinetosomes. They are connected line that we call as a kinetodesmata. Kinetosomes plus kinetodesmata. Longitudinal row of kinetosomes and kinetodesmata collectively called it as a kinety. They are all the kineties are the form it as a the added with the motorium and form it as a infraciliary system. Kinetosomes, kinety means I'm writing here definition, longitudinal row of kinetosomes plus kinetodesmata is called kinetodesmata, collectively called kinety. Here, where the cilia is arise, that we call as a kinetosomes. Joining that kinetosomes is called as a kinetodesmata, collectively called it as a kinety. Here it is present in the paramecium. Here example is a paramecium. Next, one more is there. The difference between the proter and opiste. Here, this is also one the VSAQ important. This one is the difference between the proter and opiste. Here, difference between proter and opiste. Already we discussed in the transverse binary fission of the paramecium. Write down like this only. What should put the heading? Proter. Right, like this simply. In the transverse binary fission of transverse binary fission of paramecium transverse binary fission of paramecium forming anterior daughter individual is called anterior daughter individual is called proter. And if you want one more sentence, you write it. Proter takes the anterior contractile vacuole from the parent. Remaining organelles, they can prepare their own. Next, what about the opiste? Opiste same like that only. You write it the same. In the transverse binary fission of the paramecium, forming here instead of anterior, here you write it as a posterior. Posterior daughter individual is called opiste. This is they take the posterior contractile from the parent remaining organelles, they can prepare their own. Here, this one is about the difference between the proter and opiste. Next, one more. The diagram is there. That is the TS of the flagellum or the cilium. TS of flagellum. Actually, the flagellum and the cilium both are having the inner side kinetosome is present. That kinetosome is equal in the both. How it is there means, see, the outer is having the 9 plus 2 tubules are present. Here, what the 9 plus 2 tubules means? See this one. Center singlets are present. Centrally, 2 singlets are present. Single microtubules are present like this. And the surrounding of that, the doublets are present. Here, see like this. 9 doublets are present. This is a 1 doublet. 2. There are 3, 4, 5, 6, 7, 8, and the 9. Compulsorily you write 9. The TS of the flagella diagram they gave you centrally 2 singlets you write and surrounding the inner membrane, inner sheath you write. And after that surrounding, they are called as a peripheral doublets. Between them, they are joining. That we call as the spokes are there, radial spokes. They are attached to the central, the inner membrane. That we call as a radial spokes are present like this. And also, this one is having the dining arms are present. See this one, small arms are present here. For attachment purpose, they are having the dining arms are present. Small structures are there. They are called as arm-like structures are there. They are called as dining arms. While bending movement time, the dining arms are joined and keep it the microtubules one position. Here, this one is a diagram of this one, and I label it. See, this one is these are called as a central. We call as a singlets. 9 plus 2 condition is there. 9 doublets are present. 2 singlets are present. Here, these 2 are the doublets. Singlets. Sorry, singlets are surrounded by the membrane that we call as a inner sheath. Inner sheath. Surrounding of the inner sheath, 9 doublets are there. Each and every one, red color is there that we call as a doublet. How many are there? 9 doublets are there. 9 doublets are having the small arm-like structures are present. That we call as a dining arms. Dining arms are there. Here, next the arrow mark-like structures are there now. They are called as a radial spokes. Here the microtubules in the doublets also. One is called as a microtubule. One is called as a B microtubule. Here next this outer is called as a outer sheath. Outer sheath. This one diagram also important. Here this one is about the flagellum. TS of the flagellum. We discussed the VSAQs. One is the kinetic. Second one is the distinguish between the proter and opiste. The TS of flagellum from this 5th lesson. Tomorrow we are already we completed the 6th lesson SAQs. What SAQs? The parasitic adaptations we completed, and the next the tobacco adverse effects we completed, And also the means some two questions are left. Prevention is better than cure, and the adolescence, the addiction and dependence. Three questions are left, but I'll take the all the SAQs of the all the means all the important SAQs. The next class, tomorrow's class, we start with the sixth lesson SAQs. In the seventh lesson, already 3 diagrams are there. That already we finished. What are the diagrams? The mouth parts of cockroach, the ommatidium, and the next one is the salivary glands. 3 diagrams are important in that. That you practice it. Here, tomorrow same time we meet.